A day seems simple: sunrise, sunset, repeat. But in astronomy, a day is how long it takes a planet to spin once on its axis. Earth's day is about 24 hours, but our cosmic companions dance to different tunes. Some planets are slow, some are fast. Their days are a key to understanding their unique characters. Let's embark on a tour of our solar system, experiencing a day on each planet. Get ready for some surprises. Think of it like this. Imagine a merry-go-round. Each planet is a rider on this cosmic carousel. The speed at which they spin determines how long their day lasts. Buckle up, as we are about to explore these celestial carousels. Let's start our journey from the closest planet to the Sun and work our way out to the distant reaches of our solar system. Mercury, the smallest planet, is a slowpoke. It takes a leisurely 59 Earth days to complete one rotation. But there's a twist. Mercury's orbit around the Sun is very eccentric, meaning it's oval-shaped. This, combined with its slow spin, creates a strange phenomenon. One Mercury day, sunrise to sunrise, is actually 176 Earth days long. That's twice as long as a Mercurian year, which is just 88 Earth days. Bizarre. Venus, our hot and hazy neighbor, is even weirder. It rotates so slowly that its day is longer than its year. A Venusian day clocks in at a massive 243 Earth days, yet it zips around the Sun in just 225 Earth days. Talk about backward. And to top it off, Venus rotates in the opposite direction to most planets. This retrograde rotation means the Sun rises in the west and sets in the east. Venus definitely marches to its own beat. Mars, the red planet, offers some familiarity. Its day is very close to Earth's, at 24.6 hours. This makes it a prime candidate for future human exploration. Imagine experiencing a Martian sunset, just a little longer than our own. A Martian day, called a sol, is a key unit of time for missions like the Mars rovers. The similarities in day length between Earth and Mars suggest that a transition for humans to living on Mars might be easier. Of course, we'd need to solve that whole unbreathable atmosphere issue first. Now let's head to the gas giants, where things get really interesting. These colossal planets, located in the outer reaches of our solar system, are not only massive in size, but also exhibit some of the most fascinating rotational characteristics. These massive planets spin much faster than their rocky counterparts. Their rapid rotation is a result of their immense size and the conservation of angular momentum from their formation. Jupiter, the largest planet in our solar system, rotates once in just under 10 hours. This means that despite its enormous size, a day on Jupiter is less than half as long as a day on Earth. This rapid spin creates powerful winds and the famous Great Red Spot, a storm larger than Earth. The Great Red Spot has been raging for centuries, driven by Jupiter's fast rotation and complex atmospheric dynamics. Saturn, known for its stunning rings, also spins quickly. Its rapid rotation contributes to the planet's unique and beautiful appearance. A day on Saturn is about 10.7 hours long. This swift rotation is responsible for the planet's oblate shape, where it bulges at the equator and flattens at the poles. The rapid rotation causes Saturn to bulge at its equator, giving it a slightly squashed appearance. This phenomenon is known as an equatorial bulge and is common among the gas giants. Uranus is an oddball in the solar system. It's tilted on its side, with its axis almost parallel to its orbit. This extreme tilt is believed to be the result of a massive collision with an Earth-sized object long ago. This unique orientation means its poles experience decades of sunlight followed by decades of darkness. This unusual pattern leads to extreme seasonal variations on the planet. A Uranian day is about 17 hours long. Despite its tilted axis, Uranus still rotates relatively quickly, contributing to its dynamic atmosphere. Neptune, the farthest planet from the Sun, has a day length of about 16 hours. Its rapid rotation is a key factor in the planet's atmospheric conditions. Its blue atmosphere is whipped by supersonic winds, driven by its rapid rotation. These winds can reach speeds of up to 1,500 miles per hour, making Neptune one of the windiest places in our solar system. The rapid rotation of these gas giants not only shapes their physical appearance, but also drives their dynamic and often extreme weather patterns, making them some of the most intriguing objects to study in our solar system. As we venture farther out, the diversity in day lengths continues. Dwarf planets like Pluto have days that can last for several Earth days. Some moons also have fascinating rotational characteristics. For example, Jupiter's moon Io is tidally locked to Jupiter, meaning it always shows the same face to the planet. This results in a day on Io that's equal to its orbital period around Jupiter. The exploration of day lengths in our solar system is a journey of wonder and discovery. It reminds us that even something as seemingly simple as a day can be full of surprises when we look beyond our own planet.